Hey guys, so Rajat here. Today we are talking about leetcode 659, split array into consecutive subsequences. So this problem is a more complex version of the previous problem which we saw, which was basically this one, divide array into sets of k consecutive numbers. So if you want, you can go and see that video first. So anyways, let's start. So uh, given an array, integer array, nums that is sorted in ascending order, return true if and only if you can split it into one or more subsequences such that each subsequence consists of consecutive integers and has a length of at least 3. Okay, so basically what it is asking you is that it's giving you a integer array nums, and from that nums array you have to basically make some subsequences, right? And each of the subsequence should contain consecutive integers, and none of the subsequence should have length lesser than 3, right? So the first example here, like if you look at the first example, so here the first what you will do is you will start taking 1, 2 and 3, right? And so what is the k which is given to you? It's oh, there is no k, right? So basically first you are trying to create a sequence like 1, 2, 3, and another sequence which you can get is a 3, 4, 5, right? So you can make three sequences from this array, and these both are of length 3, right? Greater than or equal to 3, so these are of 3 length, so this is true, right? So yeah. Okay, and then the second example, if you look at it, so in the second example, if I try to make a if I try to make a sequence, right? So what are the sequences which we can make? So we can make a 1, 2, 3, 4 and a 5, right? And how does it seem that we are obtaining that? So maybe you start with a 1, look at 2, look at 3, and then if you look at 3 again, it's a duplicate, right? So you can't take it. So then you greedily take a 4 and then you take a 5. So you end up with a 1, 2, 3, 4, 5, right? And then you start off from a remaining 3 here, take a remaining 4, take a remaining 5. So yeah, and then you end up with a second subarray called 3, 4, 5, right? Uh, so in this case, the length of all these two subarrays is greater than 3. So essentially, your answer is still gonna be true, right? So yeah. Let's look at the second case. So in the last example, like if you look at this example here, if you start taking the elements, right? So you will start taking the, so let's continue the same logic which we tried to make in this example. So it's like you take a 1, then you take a 2, then you take a 3, and then you take a 4, right? And you cannot take another 4 because it's a duplicate, and then you try to take a 5, right? So what you are essentially ending up with is a 1, 2, 3, 4, and a 5, right? And in this case, the remaining array will only be of length 1, right? Because that is 1, 4 which we didn't take. So even though this is fine, right? So this subarray which you obtained is fine, right? But this is wrong because its length is less than 3. So your answer has to be false, right? Cool. So then we will try to basically form this, take the same example and try to think of it in another way, right? So if you look at this, right, and if you try taking a subarray, so let's say that I took a subarray of length 3 only, okay, and I took another subarray of length 4, 4, 5, right? So the first subarray would have been 1, 2, 3, right, and the second subarray would have been 4, 4, 5, right? But this is wrong because in this two fours cannot be there. Okay, so that's why in whatever way I take a subarray of this given example, the answer I'm gonna obtain is always gonna be a false, right? So yeah, so that's why the answer which is present in this question is false. And if you look at the constraints, then the length of the array is a pretty long length, right? So what we should be aiming for is basically uh, linear time solution, right? Because the length is too much. So if you take a quadratic, it's gonna run into 10 to the power 8. It's gonna explode up, right? So cool. Yeah, so the question also mentions that the nums is sorted in an ascending order. Okay, so the way I go about it, I went about this problem. So I was not able to solve it beforehand, right? But once I saw the solution, then it took me a lot of time to actually understand it, and around 1 or 2 days. So that's why I made this video. So anyway, so the way to go about this is, so let's start looking at this example first, right? So whenever I am given a question, I try to think of it in terms of examples. So from this, I want to make a subarray of size greater than 3, right? So size should be greater than or equal to 3. So the first thing which came to my mind was that, okay, so it seems that you want to construct the you are given the arrays in sorted form, right? So array is in sorted form. So and you want a subarray of size greater than equal to 3, and this property should hold for all the subarrays you choose, right? So I tried to basically choose a subarray greedily, and I thought that, okay, it should be the longest one which I can take. So basically I thought that, okay, what we can do is, since this is already sorted, right? So we can choose the 1 2 3, and we can drop the 3 because it's duplicate, and then 4 and 5, right? So in this way, basically what we are trying to do is, so my idea had been that greedily take a subarray until entire length of array is reached. Okay, so in this case I tried to make a subarray of size 1 2 3 4 5, right? And then the thing which was remaining was size 3, right? Uh, so yeah, so actually, because here if you look at this single index, this 3 is not chosen, so this will be the second subarray which gets formed by this logic. But yeah, so I would have told that the answer is false, right? But actually the answer was true, right? So the answer for this problem was that it was 1 2 and a 3, right? And then a 4 and a 5, right? So sorry, it was a 3 and a 4 and a 5, right? So basically this was the answer, which was a true, because you can form two subarrays of length 3. But the greedy approach to form the largest subarray actually failed in this case. So yeah, so at this moment I was like, okay, then what we should do. So the next option which we can do is basically start to understand that, okay, can we take the same greedy idea that, okay, we want the length of the array to be at least 3, right? So since I'm trying to form a subarray of size greater than 3, right? So I'm trying, on earlier logic I was trying to form the subarray till the entire length was exhausted. So I formed this 1 2 3 4 5 entirely for this example, right? So then the things started creating problems, right? So to explain this concept, let me give you another example. Okay, so suppose I'm giving you an example like 1 2 3, okay, and then a 4 and a 5, right? So in this case, if I greedily take the entire thing, right? If I choose the entire subarray greedily, so I can choose that, right? So I can choose 1 2 3 4 5, cool. So that doesn't create any problem, okay. But yeah, so let's make a small change in this example now. So now let's start keeping um, a new duplicate in this, right? So if I introduce a new duplicate in this, at that moment what happened is that, had I taken the entire subarray, so had I taken the array greedily, right? So had I generated this, then a 3 would have been left alone, right? Okay, So basically, what was the problem? The problem was that the answer was looking something like this, right? 1, 2, 3, and a 3, 4, 5. Uh, when I saw this three, right? So when I saw this three, actually, that three, a better way would have been that it's three basically starts a new subarray of its own, right? So earlier I had just stitched this three to this two and three, and then continued with 4 and 5, and then this three was left alone, right? But a better way would have been that, okay, I find form a first subarray lazily of size three, right? So I form a 1, 2, 3 subarray, and then when I look at a new number, right, I look at the three. At that point, I start a new subarray, right? I start a 3, 4, 5. So so this is the second logic which I came up with. That so my second logic was that whenever you see a duplicate number, okay, so the logic which I thought was something like this, right? That try to form a subarray of size 3 exactly, okay? Because if you form it greater than 3, then you run into this problem, right? Which was 1, 2, 3, 4, 5, and then you were left with a 3. So try to form it of size 3 only, and then if you are basically if you encounter a duplicate, right? So if you encounter a duplicate, then try to start a new subarray, right? Yeah, if I look about if I try this logic for this example, so 1, 2, 3, 4, 5. So first I will build a subarray of size 3, which will be a 1, 3, 1, 2, 3, right? And then I see a duplicate, which is a 3. So at this moment, instead of just taking this 3, I need to basically take care of this 3, right? Because it's duplicate, so it can't go to 1, 2, 3, 3. It has to start a new subarray 3, 4, 5. So I start a new subarray at this point. But then when I thought about it in more detail, then the problem started coming up in examples like these, right? So consider a simple example like 1, 2, 3, 4, 5. Okay, so yeah, just a moment. Sorry, I'm wrong. Yeah. So try to think about this example. Okay. So in this case, okay. Uh, yeah. So in this case, the problem is that so first you take the unique elements, right? 1, 2, 3, and then you encounter a duplicate. So you start off with a new element. So in this case, when you start off with the new subarray, then okay, so then it's of length 2, right? And the answer has to be false. Okay. Uh, then there was so till now it seems that the logic which we are trying to say is fine, right? So let's have a look at this example to for me to explain to you what I'm trying to say. Okay, so let's take a look at this example. Okay, so just a moment. Yeah. So if you take a look at this, so let me delete up all this stuff, right? So if you take a look at this, sorry, yeah, if I take a look at this example, right? So what I am saying is that first I will try to form a subarray of size 3 exactly, right? So it has to be 1, 2, 3. So first I will form this, right? And at this moment, I have taken these three elements, right? And then what I'm doing is I'm saying, okay, I encounter a 3 again, right? So I encounter a 3 again. So at this moment I will start by forming a new subarray from this new 3, right? And go till 4, right? So then I form it here, right? And I take these two elements, right? And then I encounter this 4 as a duplicate again, right? So I encounter this 4 as a duplicate again, right? And then this 4 will start off a new subarray of size 5, right? And finally, I will end up with a 5, right? So yeah. So so here the problem is that you can see that the number of subarrays which we end up with this are 4, right? only one of them is having a length 3, and we would have returned false here, right? Because we formed these three subarrays of length 2 or 1. So but actually the actual answer for this had been a 1 2 3, right? And uh, it had also been a 4 and a 4 and a 4 and 4 and a 5, right? 3 4 and 5, right? So it had been this, right? But what had we gotten? So this one was the answer, right? This one was the actual answer which you wanted, right? So yeah, so see, what I'm trying to say is that, okay, when you encountered the first duplicate, when you found this 3, the decision to start a new subarray seems to be correct, right? Because you're getting 3 4 here, and then you're getting a 3 4 here, right? But when you are looking at 5, right? So when you are looking at 5, at that point you started to basically start off a new subarray here, right? So this was wrong. So the idea is simple, that okay, so that you start a new subarray only if it cannot be merged into a previous set. Okay, so you can only start a new subarray if it cannot be merged into a previous set. Okay, so what does this look like? So it actually means this, that suppose I gave you this array, right? And then so the first step here, right, is this logic which we came up with, that just a moment, what did I wrote? Yeah. So so this was the thing, right? So this was the thing which we came up with, right? That try to try to basically form a subarray of size 3 exactly. So for this example, we will start, right, and we will try to form a subarray of size 3, right? So we will form a subarray like 1 2 3. Okay, and then we encounter a duplicate, right? So if you encounter a duplicate, then it means that that duplicate can start off another subarray, right? So cool. So you start off a new subarray here, right? A 3, and then you look at the second element, and um, you look at this 4, right? At this moment, you continue, because you know that this 4 can be essentially stuck towards the end of 3, right? So you try to put your 4 here, right? And then cool, and then when you look at this 4 again, which is a duplicate, at that moment you check whether so till now you have essentially formed these two sets, right? So uh, yeah, so just a moment, let me think about this. Oh, I'm wrong, sorry. So yeah, so it is like this, that first you formed a subarray of size 3, right? And then when you saw a duplicate, right, at that moment you knew that, okay, whatever I have formed is of size, it contains 3 at the last, so I can't do anything. I have to start a new subarray of size starting from position 3, starting from 3, right? And then you were able to take this and form a new subarray, right? And then you look at this 4. Okay, so the point here was that if you look at this 4, then you don't need to basically okay, yeah. So if you look at this 4, so at this moment you greedily check, right, that does this 4 stick uh, below anything what I have seen yet. So yeah, it will be like yes, that you were able to till now this was a sequence, right, which you had already made. So why don't you start by sticking 4 here? Okay, and then once this is done, right, so you stick 4 here, so it becomes part of the lower sequence, and then you look at another 4, right? So the 4 here will basically go to the sequence which you already constructed. So this sequence had a 3, right? So then you construct a 4 here, right? And then you look at the 5. So does this 5 basically stick to anything which has been seen till now? So So yeah, you have two lists which are there, right? And you want the 5 to be stuck here, right? Okay. And then you look at 5, right? So this 5, can it be stuck anywhere where in any list which we have taken till now? So basically, you look at this 5 and you say, yeah, this 5 can be stuck here, right? So yeah, so this is the thing which the algorithm looks like. So first, you start off from a point and you try to construct a minimum sequence of length 3, okay, and then whenever you find a new point, you try to check whether it can be stuck in front of anything which you have already seen, and if it cannot, then you try to find a subsequence of length 3 starting from that, okay, and even if that fails, then yeah, you are essentially screwed up, right? Let me take a simple example. So suppose you are given something like this. So here what you will do is you will start off from 1, right? And you need a sequence of length at least 3. So whenever you start off from a new with a new sequence, you try to basically form a new sequence, right? So then you take these 3 elements and then you come to 8, right? At that moment you check whether 8 can be stuck towards the end of any sequence. So no, till now you have already generated 1 2 3, so 8 has to basically start off its own, right? Because had this been 4, you could have stuck it, but we cannot do it here. So yeah, so you basically take a 8 and then you want a sequence of at least 3 length, right? So you try to add 3 elements in this, right? So at that moment you are basically trying to do that. So this is the logic, right? So you end up with 3 sets and all these 3 are of length 3. So how are you guaranteeing that what you essentially constructed is of length 3? Because every time you add a number starting from the initial part, right? If you start from this one, you will first take a sequence of length 3. So once this is formed, and whenever you look at another number, suppose this was 4, so this 4 could have been stuck to the length of 4, right? For each number, you are first checking whether it can be stuck to the end of a sequence which was already generated, and the sequence which was already generated was guaranteed to be of length 3, because that's what your greedy approach looked like. So even if got stuck, it would have still remained of length greater than 3, right? And in case it cannot be stuck anywhere, then you can greedily take the future elements of length 3 to form a sequence of length 3, right? So cool. So what does this algorithm look like now? So we have understood this from the intuition point, right? But how does this example uh, look like in a real world? So the idea is that you first keep a frequency map, okay? So you first keep a frequency map. So here, if you can, so let me continue it with the same example, okay? So for this example, the idea is that you build a frequency map, okay? So there will be twos, and yeah, there will be 4 and 2s, and then there will be 5 and a 2, right? And then you start off from the first element, okay? And you have basically a map which contains like a list of a number of subsequences, right, which end with a given element. Okay, so I will tell you what it means. You want to construct a array of size 3. So you start with 1, okay, and at this moment you check is there a number like 1 minus 0, because you could have stuck this number before. So is there a number like uh, which is there a sequence which ends in 0? So right now there is no such sequence. Your map is empty. So at this point you will start by generating 3 numbers, right? 3 numbers in a set. So you will put a 0 and a 1, right? And since this sequence which you have discovered now is ending with 3, right, and you have discovered a single set of 1 2 3, right? So maybe I can tell you that this is the output, right? So you have discovered a single set of 1 2 3, right? So in your map you will start by adding a 1, right? So yeah, and then you will look at this 3 again, right? So you will look at this 2, and in the next iteration you will go to so in the first step you were basically present here, right, and you had built this frequency map. You did this operation for 1, and then you move to 2, right? And the 2 is 0, right? 2 is 0 meaning that okay, it was already a part of the subarray which you took earlier, so there is nothing which you can do right now. And then you come to this 3, right? So at this point, you check whether this 3 can actually be stuck in front of a sequence which was already discovered. So the sequence which you discovered was 3, right? So can this 3 where you are present currently, can it go behind this 1 2 3? So it cannot, right? So because it will yield 1 2 3 3, which would be a duplicate, and that's not allowed. So how do you check that? You look at the element, right? 3, and you subtract a 3 from a 1, because so you search for a 2, right? So at this moment you search if a sequence ends in 2, right? Ends in 2. So there is no such sequence which ends in 2. So because all the map contains is a 3 comma 1, right? It shows that there is a sequence ending in 3, and there is one such sequence. So at this moment what you will do is you will try to create a new subsequence starting from 3. So you will create a new subsequence of 3 size. So I'm decrementing the counters by 1, and you will start off with a new subsequence, maybe like 3 4 5, right? And then you come to 4, right? So for 4, you check whether 4 can be stuck in front of a sequence. So yes, it can be stuck here, right? So if it can be stuck here, then how will you check it? You will check whether 4 minus 1, which is a 3, whether 3 is present in a map. So yeah, 3 is present, right? So what you will do is you will try to stick 4 here, right? And at this moment inside the map there is no sequence which ends with 3. So only a sequence starts with 4 and ends, only a sequence ending in 4, right? Yeah, so that's the thing. And I also forgot to keep a 5 here, right? Which was when you discover 3 4 5. So and then you put this as a 0, and then you look at 5 and you check whether 5 can be stuck whether 5 can be stuck below any sequence. So yeah, it can be stuck here, right? So at that moment you can put a 5 here, and then you can delete, because in the map there is no more any sequence which ends with 5, because both the sequences are ending with 5 now, and you can increment the count of the 5 as 2. So by the time you are done, you know that okay, I have generated 2 sequences, both of which end with 5, right? And that's pretty much it. And let's suppose that instead of here next finally you had ended up with a 7, okay? And so then when you come at 7, so you check whether 7 minus 1 6, is there any sequence which ends with 6? No, right? 7 can't be stuck to either of these. At that moment 7 tries to form its own array. So it tries to form a array like 7 8 9, right? Because we need a minimum of 3 length. But the problem is this won't work because your array only contains 7, right? So cool. So this is like a dry run of the code which we are trying to do. So let me try to implement it quickly for you guys now. So first, what you need is a frequency counter, right? A frequency counter for your a frequency map, which is essentially doing the same operation here, right? Which is building this frequency map. So your frequency map will. So let's import collections of Python here, right? And then it's basically a collections dot counter of nums, right? It will be basically a hash map, and then there is a map which is tracking like what are the sequences which are ending. So here this map is tracking like as you're discovering the subarrays, what is the last element which you have seen, right? So which you have added to a sequence. So let's call this end, right? So end is a map, and to this map basically this is a map of a default dictionary, right? Because okay, and now what you want is to basically iterate through your array, right? And then if your so you iterate through your number, right? And then the first time so let me reset this first for you. Okay, so there is a 1 1 2 1 3 2, right? And 4 is 2, and 5 is a 2, and 7 is a 1. So first you want to basically only choose the numbers whose count is 1, right? Because So you want to choose a number, you want to basically start forming the subarrays for the numbers whose count is positive. Uh, so that's what we are gonna try to do. So if the num is, so if C of num, right, is basically greater than 0, at this moment, try to check whether num can be stuck behind already discovered sequence, right? You are, if basically you are looking at 4, so you want that can 4 be stuck to the end of a sequence which ends with 3, right? So if end of num -1, right, is greater than 0, so in that case, basically what you want to stick the number there, right? So you will first decrement that number from the counter, right? Because you're already if because you're already sticking that number inside new inside a already existing thing, right? Uh, yeah, so that's fine. And then what you want is your subarray will no longer end, right? Okay, let's forget this check for now. Let me just put a simpler thing. Okay, so if C of num, right? So if the number is greater than 0, right? If the number is greater than 0, okay, and if so next you will try to form a sequence, right, greedily. So if C of num plus 1, right? If C of num plus 1 and C of num plus 2. So if you are starting off with 1 here, right? So you are starting off with 1 here. So you want to form 1, 2, 3, right? And then 2 and 3 should be present in the map, right? So at this moment, what you will do is that if C of num plus 1 and C of num plus 2. So at this moment, what you will do is that you will decrement the counter of 1 by 1, right? Because here as soon as you form a sequence like 1 2 3, so the 3, only 1 3 will remain, right, which might basically be used in future. So that's the case. So and then you do C of num plus 2, like minus equal to 1, right? And then you basically do the same operation for the num, right? And uh, yeah, and basically now your sequence which is formed is essentially 1 2 3, right? It's a 1 2 3, so it's ending with 3, right? So you want to basically push the num plus 2, right, to the end. Cool. So this is what you are trying to do, right? And otherwise, if the so if you are like in this situation, in this case, right, when you had a 7, right, and you were trying to search for 8 or 9 and they didn't exist, so you knew that, okay, I can't form a subarray out of this right now, right? So because num plus 1 and num plus 2 are not present, so you are actually returning a false in that case. And then if everything is going fine, then you are returning true, right? So cool. And let's talk about the situation when so yeah, so for this, like, you first created a array, right? 1 0, so and then 2 was 0 and 3 was 1, right? And then you came up with pushed your 3 comma 1 to the map, right? And you were able to form subarray like 1 2 3, right? And then you came up to this 3 now, right? So at this moment, you check whether the 3 can be appended before any sequence which ends with a 2, right? But no sequence ends with a 3. So you essentially proceed forward, right? So you start off with a new sequence in this case, which is like so yeah, which is like a 3, 4, and 5 in this case, right? So you have to actually form that, right? So once you form that, and then these two counts will decrement by 1, right? And then you come to this 4. So at that moment, when you look at the 4, you want to check that this 4 should be stuck in front of uh, a thing which you have already discovered, right? So uh, just a moment. So yeah, so this would be 5 comma 1, right? Because we have essentially discovered this array. So yeah, so once this is done, you what you will do is that so for this 4, right? For this 4, you are checking whether 4 minus 1, 3 is present in the map or not, right? So if it is present, then you delete this guy and you stick your 4 in the output, right? And uh, you have a new subarray, right, which is having a 1, right? So this is what I need to implement here, right? So uh, if so if you are looking at a number, right, and if a sequence is ending with a num minus 1, right, at that moment what you want is to basically delete the num minus 1, right, and you want to stick your number to the end, right? So end of num, right, plus equal to 1, you want to stick your number to the end, right, and you wanna basically uh, and you want to decrement the counter because you have already used that element, right? So this is what the situation should look like. So if I'm looking at this 4, so I want to check whether this 4 can append itself to the end of a sequence, right? So it can append towards 3, so I put a 4 here. So this is what this piece of code will do. So in the end, if all the things go fine, it should continue, otherwise it will return true in this. So yeah, let's try to run this out. Yeah, so let's try to submit this once. Okay, cool. So let's try to think what the error here is. Uh, okay, so so you okay, so you go to here. Um, so if your C of num is greater than 0, right, and if C of num plus 1 and C of num plus 2, right, so then you are decrementing these two numbers, right, and then you are decrementing this and you are incrementing how the numbers are gonna end. Okay, that is fine. um, and then if we look at C of num, right, and if you look at okay, is if end of num minus 1 is there, then end of num, okay. hmm. Hmm. So 1 2 3 3 4 4 5 5, okay. uh, hmm. So oh yeah, it should be elif here, right? So yeah, so because you are either sticking the number to the end of a number which was seen, or you are trying to basically start a sequence from there, right? So uh, yeah, so I think that was the mistake which went here. So yeah, so this essentially passes now. Okay, so cool. So this was a question which was bit on a difficult level, but yeah, so it's a frequently asked question in other places. So this tells us that the greedy concept here was that you try to generate sequences of length 3 every time, and when you see a new number, then you try to basically append it to the end of a sequence which was already generated, or you greedily start a sequence of length 3 from that number. Okay, and to find the continuous numbers, basically you are keeping a frequency counter, and then the novelty of this problem is that to track the new so to track like which of the numbers, which of the sequences which you have already generated, you need another map, right, which you call as end in this case. So you can solve this problem in order of n time, because you are just looking at each number once, right? So you can solve this problem in order of n time and order of n space, uh, essentially. Yeah, so and you can see that this solution is like 91.6% faster. Yeah, Okay, cool. Thank you.